example with this manifold. I'll give you sort of my 3 main steps for my thought process when I design a part for additive manufacturing. So the way I approach it, first step is get rid of everything that does not serve real engineering functionality. It's all that excess material that is there. Get rid of it because it's not doing anything useful. That excess material, it increases your cost huge amount. That excess material also, that's where a lot of your residual stress comes in, because at the residual stress, it means you're going to have to heat treat it for a lot longer than if you have a nice even wall thickness. So once you've done that, you've now got just the bare minimum. So if you think about a manifold, the only thing that serves functionality on a manifold is the pipes, which means your manifold in a perfect world should look like a network of pipes, not like a big cube. Next step, decide what your print orientation is going to be. Is it going to be vertical, sideways? From there, you try to go through the steps to eliminate support material wherever possible. So the 2 main techniques for that, 2 choices really, change the angle. So generally, support material, down-facing surfaces below a certain angle need support material. So typically 45 degrees, but that changes depending on the material and the machine you're running, which means any angle that's less than 45 degrees, you will need support. More than 45 degrees, you don't need support. The other technique that I use a lot is, if you think about your support material as being a temporary sacrificial wall that you're going to tear off afterwards, well, consider replacing it with a permanent wall that actually becomes a feature of the part. And then from there, you might have to go through several iterations to determine the absolute best orientation. So going back to our previous manifold, so effectively all I've done is I've just shelled the entire part, getting rid of the outer faces and all the excess material to give us that top center version, which is now a working manifold with just the pipe. So just the functional bits that serve a purpose of the manifold. From there, on the right top, you see it where I've generated the support material. So all of those blue blocks are support material that is sacrificial material that I'm going to break away. You'll notice the pipe sticking out towards the right at an angle doesn't need support because it's at that magic angle that doesn't need support. And then the other strategy, just to demonstrate it, is instead of those blue blocks of sacrificial material, you can see on the bottom left, I've replaced those with solid walls of material that now replace it and become a functional section of the part. Now, yes, I've added a bit of weight. So if weight saving was the only and absolute priority on this project, the top middle one would be the finished design, and I would suffer through removing the support material and the labor that takes. But if I can stand a few extra grams of material, potentially that bottom one might be the better option. And you can see it printed there on the right-hand side in Inconel and a nickel-based alloy. So just to give you some real costing, so these costings come straight from an online bureau. So, you know, Materialize, Shapeways, Sculpture all offer online services. And just for fun, I uploaded that square block manifold, $15,000 to print that. Now, that's just crazy. Nobody in their right mind would print that manifold for $15,000. In contrast, the shell one, you're just under $4,000, and the design for AM1 is just under $2,000. Now, I cannot make an argument whether it's worth $2,000. That now becomes a different question to what we're talking about now. But, you know, that demonstration, I guess, is that additive manufacturing really is not a choice. So it's something you have to do if you're going to be making parts for production. As I said, prototyping is a slightly different story. And I just thought I'd show you one more slide on this because it's an area that, you know, is, to my mind, I guess, one of the ultimate goals of additive manufacturing, of design for additive manufacturing, is to produce parts that are printable with a minimum of support material and a minimum of material. So everybody that has a metal printer ends up designing and printing bottle openers. It's just a handy thing that people like to give away. So this was my take on a little design for AM bottle opener. You can use it with a single hand to open your bottle. And what you see there is a little sea of them on the print plate with, you know, a fraction of a gram of support material at the bottom. And again, you'll notice if you look at the left-hand picture, you'll see where my thumb is. That whole top section is hollowed out to 1 mil thick. And again, it's removing material that doesn't serve any engineering advantage, doesn't make it any stronger. So get rid of it because that now shortens your print time proportionately. So as I said, those are my overall thoughts on design for additive manufacturing in terms of the general. There's hundreds of other rules. You know, what's the minimum wall thickness for which material, filleting the bottom of all internal corners. There's many, many other design for additive manufacturing rules that you need to follow or guidelines. But the thought process, you know, putting it very simplistically, the two main rules is design to minimize support material and design to minimize mass, the mass of material. If you start there, you're already on a good way forward towards design for additive manufacturing. As I mentioned a bit earlier, one of my hobbies is guitar. I make guitars. I make 3D printed guitars because it's something that relaxes me, I find. And it's just really to show you, I guess, my latest designs. This is something I started back in 2011. Really, I used to play a lot of guitar in my younger days, and I've been using additive manufacturing since the mid-90s to prototype parts largely. And I saw the technology getting better and better and better. So I thought, I wonder, could I make an electric guitar that is playable, that is a workable instrument? And I designed my first one, and I was blown away by how well it played, how good, it sounded like an electric guitar. So from there, I started making more and more and more and started selling them. And yeah, I'm building number 87 now. So I've done 86 so far, and I've got about a dozen of them, one of each design in my collection. And every guitar is designed for AM in the sense that these are guitars you could not make any other way. If I was making a standard solid body Telecaster or Gibson Les Paul, printing would be a crazy way of making them. But these are all shapes that you couldn't make any other way. So from a geometric complexity, they're all there. And I guess it made sense that because I was doing guitars, I was doing basses, it made sense to do the rest of the bands. I've done I think I've done 4 drum kits so far, I think 3 keyboards, and I've done 1 saxophone, which doesn't quite work. It was leaking air. So on a saxophone or clarinet, if you leak air, it all goes out the window. So I had rubber bands around it to try to seal it properly and managed to get about 8 notes out of it. And just to the left of the saxophone, you'll see one. It's called the Steampunk. But just to show you what it does, so all the gears move. And again, for those of you who are not familiar with additive manufacturing, so these particular ones are done with laser sintering, so powder bed fusion, plastic powder bed fusion printed in nylon and polyamide. So to hurt your brains, for those of you not used to that, the guitar body was printed in one piece with all of those moving gears in there, no assembly required. So that does hurt the brain a little bit. And the logo as well was also printed in silver, copper, and bronze. I think I did 3 different materials for that. One of my, a lot of my guitars are a little bit on the kitsch side because I love doing themed guitars. And one I did, I think it was about 7 or 8 months ago, was an Alien themed guitar. I loved the Alien movies when I was a teenager growing up, so I decided I had to do an Alien themed guitar. And that's the one you see there. And as I said, it's just a bit of fun, really, to show the passion I've got. And I've also always been a huge Beatles fan. So probably, I did it over last Christmas, so it would have been almost exactly a year ago. I did a Beatles themed bass. So it's, shaped after Paul McCartney's Hefner bass. It's got the score for Yesterday on the front, so the music you see there. And inside of that is, the I guess, iconic Beatles scene. And just to show you some close-ups of some of them, you got the Yellow Submarine, the Sgt. Pepper's drum kit, George Harrison's guitar, John Lennon's glasses, the Abbey Road scene where they're walking across Abbey Road. Now, my wife very kindly painted the inside of that. So it was printed in nylon, so it came out of the machine white. And my wife hand painted all of the inside parts you see there with fine paintbrush. It took her hours and hours, well, days and weeks to do that. And she hated me by the end of it. But she did a brilliant job on it. A really, really fantastic job. But seeing the pain of painting the inside of the guitar got me inspired to give a go to a technology I'd never really used much before myself, which is printing in full color. So this is the latest guitar I did about 3 months ago, printed in full color. Also in the lab, we were in the process of buying a full color printer, so I needed to test the Stratasys J750 versus the Mimaki, one of the Japanese full color printers. So the one you see there is printed on the Mimaki machine, and it comes out of the machine as you see it there with the wood grain on there. The dragonfly wings, if you look at them carefully, are transparent. So it shows you the level of intricacy you can get with these full color printers in a nice way to go. And as I said, the downside with this particular guitar is it's printed in acrylic rather than nylon, which means if you dropped it, chances are it would probably not last all that well, but it does look magnificent. Whereas the nylon ones, if you drop one of those, well, it's probably not going to damage the guitar all that much. So as I said, this got me, and our color printer arrives in, I think, hopefully this side of Christmas or early in the new year. So you may see a few more color guitars coming out. I mean, just to play, to explore the technology, to see what you really can do. So as I said, guitars not strictly designed for additive manufacturing, other than on pushing that complexity, to the maximum. So the question then becomes, well, additive manufacturing is an amazing technology, and as a innovation, it's absolutely incredible. But you think, well, what's missing? Why are companies not using it left, right, and center? So unquestionably, to my mind, we need more materials. We have about a dozen different metals to choose from, and probably the same in polymers. We've got a few ceramics, but we need a greater choice of materials. Things like polypropylene, polyethylene is a highly flexible material that can do, say, a living hinge, still a challenge with a lot of material. Unquestionably, we need better surface finishes. So you got that center, that in the bottom center, you've got that swatch of surface finishes. Today, we're probably on the right-hand half of that swatch. Even the very best, never mind metal, even the very best, material jetting or stereolithography technologies are probably still in that middle section. Once we get to the left section of that swatch, I think you'll very quickly see more companies adopting it for real products. And of course, really important certification, qualification of parts. If you're going to print parts that you're going to sell, or you're going to put them on a car or an airplane, you need to be able to guarantee and certify the quality of those parts. And again, design for additive manufacturing plays a big role in that. If you're designing parts entirely differently to the way you've made them for the last 100 years, do we need new ways of certifying, of testing them, and so on? So questions that I can't entirely answer, but things that are needed to work. Oh, one other thing we definitely need is faster machines. On a metal printer, if you're, a print job of 10 hours is a fast print job. You very easily have jobs that are 40 hours or several hundred hours to print. So we need printers that print a lot faster. And that's where a large part of your cost comes from, is the machine time when you're paying for 300 hours of printing. Unquestionably, we also need better design tools. So I talked a little bit about topology optimization. Other tools like lattices, particularly now that people are getting excited about tools like N-topology for doing gyroid structure for heat transfer, really amazing tools, but we need more of those. And I think we also need more of those tools integrated directly into our CAD systems, so that in whatever CAD we're using, whether it's Creo, CATIA, SolidWorks, doesn't matter, ideally being able to do everything in one software package would be nice. Whether that'll ever happen, I am not entirely sure. And I think finally, we need to update our engineering design programs to have design for additive manufacturing included in our education. So students coming out of university or even high school have an awareness of additive manufacturing in the same way they do about injection molding or casting and extrusion, and know some of the intricacies of designing for it. And one of the reasons why I was really excited to find out about this design for additive manufacturing network that you guys have started, and that this event is about. And I think a fantastic initiative, and I think that is what we need to get industry to adopt additive manufacturing in a much greater way. And I'm more than happy to contribute, to help, to assist in any way I can. So just feel free to ask me if there's anything I can do to help the initiative on the whole. So I think I'll leave it at that and really open it up to you guys if there's any questions, thoughts, ideas that spring up out of any of this in terms of what I've talked about, or if there's any other general questions.
Thank you so much, Olaf. It's been a terrific presentation. I've seen your guitars online on LinkedIn, but really hearing from you the design of the guitar has been really amazing. And I think also in the chat, people listening to your presentation, they were really impressed about the guitars. They're really amazing.
It's a bit of, everybody loves a bit of eye candy, but as a demonstrator of 3D printing, they're really great examples because everybody wants to look them, touch them, play them, and feel them. So it does make a good demonstrator for sure.
Absolutely, absolutely. Thanks. So I absolutely welcome the chat and the attendees to send questions to Olaf. If you have any questions, I would really encourage you to ask questions to Olaf. And I can break the ice because I have one question for you. So which kind of software do you use to design the guitars? Because they
So,
have very intricate shapes. So I was really wondering.
yeah, look, I probably used the wrong software for it. I do them all in SolidWorks because it's what I'm used to. I've used it for a million years, or since early 90s, or when in 96 or 97. So it's what I'm used to. But for organic shapes, it's probably not the easiest to use, but you use what you used to. Now I'm also using a lot of in topology, which I haven't used for guitar, but I've got an idea for a guitar that I will be using in topology to do various both surface textures and gyroids in there for a very funky guitar. But yeah, my main tool is SolidWorks, and then for post-processing, I use NetFab, I use Magix, I use, well, anything I have to use.
Thank you, Olaf. Are there any other questions from the chat?
You can ask them over the microphone or via the chat. Either's fine.
Hi, Olaf. I'm Charlie from Autodesk. Not necessarily wanting to completely hijack and just take it down the guitar route, but yeah, just curious about the guitars and like how do they play, how do they sound, and who are you doing these for? Do you do them and then find buyers, or are people commissioning these?
A bit of both. Okay, firstly, I mean, they sound great. They're electric guitars. Now, I've got to be a little bit careful what I say, because guitar acoustics on electric guitar, it's a bit of a religion rather than a science. And when you say you make a guitar that's printed in plastic, people say, think I'm the son of the devil for even considering it. In fact, on electric guitar, the science is the pickups pick up the string vibrations. That's the only thing that produces sound. Now, anything that affects the vibrations of the string has a very small impact, but it's so minor. And you usually find the guitar aficionados, the first thing they do is turn up the distortion when they check the sound quality, which is probably not the best way of doing things. And if you change this, if you put new strings on a guitar, it sounds entirely different. But look, so yeah, second part of the question, yeah, I do them on, like, every guitar I make is different. Most of the time it's simple customization, like putting the name of the band on the back, and minor customizations like that. So I'm doing a Steampunk now for an American guy who wants the knobs in the exact same position as his existing Telecaster. So I'm moving everything around to give him the custom feel he wants. But yeah, I mean, mostly word of mouth. People see them online, and I've sold a couple to people who don't actually play guitar, who just wanted them for their man cave. But most of them, yeah, I sell to guitar players, yeah, guitars or bass players.
Well, they're amazing, so great job.
Thanks a lot. Cheers.
There is a hand. You young?
Yeah. Yes, I want to ask a question about you print the metal part. Did you polish it after the print, or just the print is become the better surface?
So, I mean, I guess in general, we always bead blast the parts or shot peen the parts. I mean, so the parts I showed tonight, the manifolds and that guitar, the manifold was just as it came off the machine, just bead blasted was the only finishing we did on that. The guitar, I did a lot of hand sanding and then bead blasting to give it a satin finish. But over the last 2 years, I've gotten very, very good at polishing parts to a high shine finish. In fact, that bottle opener, I think, was polished. Just on a buffing wheel. And just last week, coincidentally, we just received our Centrifugal Isotropic finishing machine. So it's like a barrel, it's like a tumbling machine where the small drums rotate in one direction at high speed and then the big drum rotates the other way. It did a fantastic job. So we put about 200 bottle openers in there at once. It did a great job in polishing. And then we burnt out the brake on the motor. So we're now waiting for a replacement brake to arrive. But yeah, today, unfortunately, most of the finishing has to be done by hand. So again, it's something to think about in your design. Can you do it the right way to make it as easy as possible to polish?
Okay, thank you.
Oh, and I can see Alan's asked a question about, has anything really challenged you from a design for additive manufacturing point of view? The short answer, I guess, is no, not yet, but I find out by doing. So, I mean, the aluminium guitar was a perfect example. That was my first experience at actually personal removing metal material, support material. As I said, done hundreds and hundreds of FDM parts. Metal support is like putting FDM parts on steroids. And that hands-on experience made me really realize the importance of design to minimize. So it's from that experience that I started learning or developing techniques to get rid of support material in the best possible way. So far, nothing's stumped me yet, but now we're just starting to do a lot of work with heat transfer. So looking at heat exchangers, for example, and that's something I don't know a lot about. I have to go back to my engineering principles from 100 years ago to relearn that and then apply it to additive manufacturing. So I'll know in a few weeks or months whether that stumps me or not. But there's always new stuff to learn, and that's what's cool, because every month, every 6 months, there's a new technology that comes out, which means you have to relearn how to design for that particular technology. And it's also why, to my mind, it's such a good catalyst for innovation, because innovation is about thinking differently. Because every new technology comes out, you now have to think differently. They make a really good catalyst for innovation. And yeah, probably the only time I've seen an engineer and an artist actually truly collaborating is when there's a 3D printer between them. Otherwise, they talk different languages, but suddenly you put a 3D printer between them and they can actually start to influence each other's ideas, which is quite amazing to see. So as I said, not quite answering the technology, but yeah, the question, but yeah.
Great, thank you. You're muted, Patrick.
You're muted, Patrick. Any other questions? Somebody's got their hand up there.
Yeah, I think there is Martin's.
Yes, thank you, Olaf. Nice presentation. I play the piano myself, so I look forward to a customized piano someday. But I was just curious to ask, in addition to the support structures and designing for the support structures and post-processing activities, do you think there are other limitations that the designer should consider when designing for AM, from your experience?
I mean, certainly one of the other ones, and I often talk about metal because it's the hardest one of the technologies to design for, but everything I've been talking about applies equally to plastic. But to give you another example, I mean, getting rid of thermal stress in a part. You know, thermal stress is what's going to cause your part to distort. Stress concentration, stress risers and sharp corners is where your part is pretty much guaranteed to fail. So simple things like filleting everything, never have sharp corners, certainly never have sharp internal corners. But while you're about it, you might as well fillet all your external corners as well. It's going to make your product more comfortable to hold, but also filleting those external corners, silly as it might sound, actually removes material, which makes your part cheaper to print. Other silly things like, you know, put logos, assembly instructions, part numbers on your part. Now, you know, it's almost silly design for AM, but if you cut a logo or you cut a part number into the part, so rather than if you cut it in, you're actually, again, removing material, you're making your part faster to print, cheaper to print. It's a win-win. You're advertising, you're branding yourself, and at the same time, you're reducing your cost. And then, as I said, lots and lots of other rules and guidelines for things like, you know, wall thickness. What's the smallest hole you can do through a part to get the powder or the resin out of it? You know, there's hundreds and hundreds of small design rules like that. But in terms of thought process, as I said, it's weight removal, heat, stress concentration, heat treatment, minimization, and support removal would be the main three. But no doubt there will be others.
Okay, thank you.
I've seen other 3 questions in the chat, but now I think we are already, if you want maybe to answer one, but we are running out of time.
Yep. Okay, so I'll answer very quickly the one about which software you recommend for topology optimization. I use Inspire a lot because it's topology optimization for dummies. But now we've also started using N-topology a lot, but I haven't yet played with their topology optimization, but we will start playing with that a lot as well. And the other one with multi-material prints, short answer, no other than the full color guitar. That was my first multi-material, even though it's just different colors of the same material. So if you're talking about rubber like the Tango in the J750, no, I've never done any of those myself, but used a lot of them.
Thank you, that's great. Okay, so I think we can move to the next presentation. And I mean, Olaf, if you want, I know that the time difference is not great, but if you want to remain at least to the coffee break, and maybe we can answer some of the questions that come up. Thank you. Thanks a lot.
Sounds good. Thank you.